And here are the last two problems of that Chapter 4 test key. And we'll look at these real quickly. Number 7 was looking at the oxidation state of everything in UF6. Well, if fluorine always has to be -1, and there are 6 of those, that gives us a negative charge of -6. We know that these have to add up to 0, so the uranium has to be 6 plus. Here we know that 3 times whatever the charge of the iron is must add up to +8. So that means that the effective charge on the iron in this compound is 8 divided by 3. And that's just kind of the average between 2 and 3, which it probably actually is in this compound, but the oxidation state, if you look it up online, if you look it up in textbooks, will be 8/3. Kind of unusual, but I thought it would be interesting for you to see that. And in problem number 8, we're balancing redox reactions, but notice it's in a basic solution. So when we get down to the bottom, we're going to be playing with changing it from acid to basic solution. So the first half reaction is written right here, and we're going to start by balancing the oxygen by adding water. The bromines are already balanced, so we're balancing the oxygen, so we're going to have to add 3 of those. Of course, that gives us 6 hydrogen, so we balance the hydrogen by adding H pluses to the other side. Now the last step here is to balance the electrons, balance the charge by adding electrons. So the charge here is -1 with, let's see if we can get that to show up here, -1 with the bromine and -1 with the bromate. So we have to add 6 negative charges to get the charge to balance out to 0. So we're adding 6 electrons. Now let's balance the other half reaction. We'll start by looking at the half reaction here. And we see the manganese are balanced, so let's move on to the oxygen. We're going to need to add 2 more oxygen right here. So to do that, we're adding 2 water. So the oxygen are now balanced. And we're going to add hydrogen. So we have 4 hydrogen here. We have to add 4 H pluses to balance that. Now to balance the charges by adding electrons. So let's see if we can do that. Here we have a charge, we have 4 plus and 1 minus, and that adds up to 3 plus. On the other side there's no charge, so we have to get rid of the 3 plus by adding 3 electrons here. So we've added the 3 electrons. Now the number of electrons that are transferred have to be equal. We can't have 6 electrons formed in one half reaction and only use 3 of them up. So we have to double this entire half reaction down here. This entire half reaction has to be doubled. So we put a coefficient of 2 on that and we double it. Now if we add that all together, that's written down here in green. There, I think we have it adjusted so we can see it all. So if we add those together, we have 3 waters of bromine. Everything that's written green is the just bringing down the reactants and products from both reactions. So now we have to deal with canceling things out. Well, I think what I did here was cancel these 6 hydrogen and 6 of those. That gave me a coefficient of 2 in front of the hydrogen ion. But then I had to add hydroxide to neutralize that. This is in basic solution. So I have to add 2 hydroxides to both sides. Notice I've added them to both sides. And so now these two hydrogens here and these two hydroxides on the left add together to make two waters. And so I'm actually canceling out waters here with waters here, and there are 4 waters I can cancel out. So 4 waters cancel out on each side, and that leaves me with 1 water. So that's how we got 1 water down here. The bromine, I should say bromide ion, the manganate ion, and we're bringing down everything that didn't cancel out. This highlighted in light blue should be our balanced equation for this reaction in basic solution. Notice it has hydroxide ions here, it's in basic solution.